Hello, I'm Joseph OM7ZZ and I would like to introduce you SMÅRF, our vector signal meter. Thanks to vector measurements capabilities and fast sampling rates, SMÅRF provides not just all kind of power and reflection measurements, but also impedance, signed reactance, intermodulation products, and visualizes power development at its oscilloscope screen. SMÅRF operates from top band up to 70 cm and measures transmitted signals from milliwatts up to several kilowatts using external sensors. SMÅRF can handle two sensors at the same time and is the most advanced vector power meter on the amateur radio market today. SMÅRF is a network-enabled device providing remote control over the internet from a tablet, smartphone or a computer. In addition, SMÅRF provides legacy standard serial port, proprietary I-Link ports, and a pair of transceiver control ports for PTT and inhibit. In addition, there is a high-purity DDS-based signal generator outputting sine tone, dual tone, pink and white noises with amplitude and frequency sweeps up to 10 kHz. Measured results are presented on dual 3-color user-adjustable bar graphs with high-contrast OLED display. User interface includes 5 buttons and rotary encoder with push function. Measured parameters are logically organized into several screens with appearance optimized for various operating situations. Screens are chained after each other and can be individually enabled or disabled. To navigate between screens, simply press the left or right button. Current screen's name is shown briefly before the screen itself. Switching sensors is as simple as switching between the screens using bottom sensor buttons. The edit buttons serve for customization of each screen, left-right buttons change edit in focus. Display parameters can be changed instantly without diving into the menu. Where necessary, menu is entered by long press of edit button. Bar graph ranges changing is always available by rotating knob on every screen. Unique to SMÅRF is its capability to provide measurements not only at the point of the sensor as every power meter does, but also at antenna feed point. In respective menu it is possible to define up to 32 different antennas representing 32 different coaxial cable feed lines connecting these antennas. Each antenna has a freely editable name. After adjusting the cable length, there are more than 30 accurate coaxial cable models available for selection. When feed line and antenna is defined, it can be assigned to bands according to the antenna's range. Once antennas are defined, on every screen it is possible to choose any of those antennas according to current operation frequency and the antenna to band assignment. Any measurement then can be displayed either at the sensor point indicated by the TX suffix or at the antenna point indicated by ANT suffix next to measurement type. SMÅRF provides measurement result not only on display but also on bar graphs. Both bar graphs can be switched to various functions, not just to show power. Top bar graph can be set to one of 12 functions including forward peak or average power, delivered peak or average power, impedance or resistance for either sensor or antenna measurement point. Bottom bar graph can be set to one of 14 functions including SWR, reflected peak or average power, reactance or phase, and dual simultaneous display of resistant reactance or impedance phase either for sensor or antenna point. Please note that the colors stick to power level even if range changes. This provides important feedback to operator about current power level. Power on top bar graph is shown in configurable 4 color separated ranges. Color and power levels can be set in bar graph menu on per band basis, allowing to customize color and power levels according to specific requirement. Settings are live and changes are instantly visible. Each screen has its own color table. This allows to customize color ranges according to purpose of the screen, so you can have different ranges for low power and different for contesting when is usually everything pushed to its limits. Bar graphs can be set to either bar or dot display mode separately following your preference or purpose of the bar graph function. For each bar graph there is a peak hold option, displaying maximal peak power for a certain time even after the power has already decreased. It can be individually turned on or off and has adjustable timing. For bottom bar graph, it is not only possible to set colors and power levels for reflected power, but also separately for SWR reading. Changes are live again, what you see is what you set. As was said, SMΩRF provides measurement results in various editable screens. First basic category screen, where I can demonstrate what instant editing means, is the standard screen. Standard screen shows simultaneously 4 editable measurements. First of them is forward power measurement, which can display incident or delivered power, the latter indicated by -REF suffix for both feed points. Then it is possible to set units to watts, decibel milliwatts, and type of power, peak, average, total peak or total average. Second field is set to show reflected power, units and type has same options as forward power. Third field can be set to show SWR or return loss, again either at the sensor or antenna point. Last fourth field shows signed complex impedance as resistance and reactance, or in polar coordinate system as impedance and phase. Each screen has its own screen menu, which allows to set displayed value, hold time and customize constants for averaging, optimal for particular purpose. This is why the standard screen is there twice by default, one optimized for CW and second for SSB mode. Although operating SMΩRF is simple and intuitive, there is really a lot of tweaks available. To not get lost and to avoid resorting to the manual every time you want to change something, we have implemented a multi-language built-in help for every editable field, every menu item, simply accessible by selecting an item and pushing the knob. Help is always there at your fingertip. Next to the standard screen there is another basic screen called large screen. It is simplified, non-intrusive screen providing just 2 measurements using large, very well visible font for the forward power and smaller one for reflection measurement. Useful screen for tired eyes after tens of operating hours during the contest or user with side problems. As every screen, large screen also allows to customize bar graphs. Forward power can be set to show incident or delivered power at either sensor or antenna point in all units and types, as it is possible on standard screen. Second measurement is possible to set to show reflected power, SWR or return loss. Large screen has also 2 copies by default, one optimized for CW and second for SSB. SSB screen combined with average forward power on top bar graph can nicely show speech compressor effect of the transceiver.
1 2 3 4 5 1 2 3 4 5 testing dial up.
Tuning is a special screen designed to help in tuning power amplifiers or antenna tuners. It provides 2 forward power readings and 1 reflection reading. It helps to keep tuning procedure simple and straightforward. When the screen is combined with complex impedance reading on bottom bar graph and SWR in reflection fields, it provides very nice feedback of how well is your load tuned to transmitter. Then without worries you can raise output power of your amplifier. The left-hand forward power value indicates the largest achieved forward peak power since entering the tune screen. The left-hand value displays the current forward peak power in watts. Next to it, forward peak power expressed in % is displayed, referenced to the 100% power setting set in the menu. Bar graphs and reflection fields are only editable fields in this screen. Reflection field can be set to show reflected power, SWR or return loss at either sensor or antenna point. Top bar graph is best to display the delivered peak power. At the bottom right corner is a small progress bar which shows the changes of output power in time. Between both values, a check mark indicates that the desired output power was achieved. Tune screen can be entered automatically from any other screen. In our example using the large screen, we enter the screen menu and enable Tune Jump option. Then if during operation a need for retune arises, either because of power drop, increased SWR or any other reason, we simply key the transceiver. SMΩRF detects constant power and automatically jumps to the tune screen where we can retune amplifier or fix antenna tuner matching. After resuming normal operation, SMΩRF automatically returns back to the screen from where the tune screen was initiated. Last basic screen of the SMΩRF is dedicated PSK mode screen we've built for PSK operators. Screen shows peak or average forward power at the sensor point, reflected power or SWR, and intermodulation products. Screen menu allows to set evaluation for wide range of speeds from PSK 31 up to PSK 1000. On the right side of the display is shown oscilloscope monitor automatically adjusting for selected PSK speed, spectrum monitor providing readout of 3rd, 5th and 7th order intermodulation products as a difference to the fundamental signal. Below, a verbal quality evaluation of the transmitted waveform is shown. Live data, oscilloscope, spectrum and IMD measurements are providing nice feedback and help for operator for quick on-air modulation level adjustment to find optimal balance between the output power and the purity of the transmitted signal. Related to PSK operation, there is a special PSK alarm. For this alarm, critical threshold of IMD products can be adjusted in the alarm menu. When higher IMD products are detected during operation, an alarm is invoked. It is indicated by one of the two dedicated alarm LEDs on the front panel and an optional pop-up window which can be temporarily suppressed as well as individually selectable alert sound. As the alarm's engine evaluates signal on the background all the time, it works on any screen, not only PSK screen. The PSK alarm is only one of the many alarms provided by SMΩRF. Let's explain the working of alarms on the SWR alarm, which is the most common alarm. Every alarm has 3 importance levels: warning, alarm and fault, and each level can have assigned a set of actions: display of pop-up window, sounding an audible alert, and interrupting of transmission. Finally, the method of alarm reset can be selected to automatic with timeout, manual or upon PTT. SW alarm can be adjusted separately for each band in 2 power ranges. The lower power range does not necessarily start at 0, allowing to set minimum power from where alarm processing starts. In both power ranges, an adjustable SWR threshold level determines one of the 3 importance levels. Any importance level can be set to be ignored. Let's demonstrate the alarm operation on an example. Operating on 160 meter band, we have set the first power range to be 20 to 70 watts. The warning level is suppressed, alarm level is set to 2.5. When SWR gets beyond the 2.5 value, an alarm level alert is invoked. For this level, pop-up window and alert sound is set. To demonstrate second power range, let's restore SWR below 1.8 and increase power above 70 watts. Now increasing SWR above 1.8 invokes warning level alert, increasing further beyond 2 invokes alarm level alert, and finally increasing it beyond 3 throws a fault. The alarm LED always indicates the current alarm importance level. Along with SWR alarm, there are low and high power alarms with settings similar to the SWR alarm. If used together with power amplifier, the 2 power ranges for each band enable to secure optimal driving and output power levels, with no need to change an alarm adjustments when amplifier is bypassed. Last alarm type is a special arsing alarm, which triggers upon sudden short duration SWR changes, which is typical for arsing events. All alarms share a set of common global settings, where different sound effects, their volume and repetition can be set for each importance level. This menu allows also to determine the behavior of transmission break in input and output, their polarity and function. Alarms have screen-related settings similarly to how the bar graph's colors are set. SWR, high and low power alarms and their importance levels can be individually enabled or disabled for each particular screen. It means that each screen can be customized for different purpose of use. Advanced screens in SMΩRF are designed for in-depth signal evaluation. First is technical screen closely related to sensor and antenna feed points, providing simultaneous analysis of both. Screen is virtually divided to left and right part. Left shows measurement results for sensor point, right evaluated values for antenna point. Antenna feed point results are always related to selected antenna. Screen can be edited at the sensor point and changes are automatically applied also for antenna point. There is possible to set units for the incident power to watts, dBm or dBW. Second field allows to show reflected power, SWR or return loss. For voltage and current it is possible to select peak, peak-to-peak or root mean square value. Bottom field selects format of provided complex transmission line parameters, resistance reactance, impedance phase, conductance acceptance, admittance phase and two forms of reflection coefficients. Small P and S switches between series and parallel equivalent reactance circuit. All provided measurements are live and all displayed parameters immediately follow antenna, feed line matching or frequency changes. Center value in the rectangle shows losses in the feed line. Technical screen provides detailed and complete overview of what happens on both sides of the feed line and helps to check losses and power ratings of the components used in matching circuits. Scope mode is all-important time domain signal inspection tool. It features all the usual triggering modes. Rolling mode is suitable for inspection of slow changing signals. Auto mode is intended for repeated signals with help of feature-rich built-in tone generator capable to generate fixed in duration or continuous single and dual sign tone, wide and pink noise, amplitude and frequency sweeps. Tone generator is based on 32-bit DDS using a 24-bit DA converter. This allows to adjust frequency and amplitude level in very fine increments down to 1 Hz and 1 microvolt. Both offset and amplitude of displayed waveform can be adjusted. There are two cursors displayed which can either move freely over the whole screen or they can track the waveform set to certain time position. Cursors display true value of their position even if the waveform is off screen. Amplitude can be shown not only in volts but also in watts and dBm. Scope mode has also the usual horizontal adjustment with resolution down to 20 microseconds per displayed dot. Waveform can indicate either average, maximum or both minimum and maximum simultaneously. Capture is usually triggered at either edge of the sampled power at an adjustable level. Optionally, external input can also serve as a source of the trigger. Auto mode is also suitable for checking compression level of SSB modulation.
Testing.
In normal mode, waveform capturing starts strictly only on trigger events. Therefore, normal mode works well for checking non-periodical signals such as CW waveform, where automatic screen redraw is not suitable. It allows very simple measurement of rising and falling time of CW elements edges, which are the main contributor to occupied bandwidth of the CW signal. It also shows the element duration jitter introduced by CW keyer, visible as varying position of the falling edge. Single shot mode is intended to display non-repetitive events. For example, it allows to capture overshots caused by poor power supply regulation or LAC circuit not present on subsequent edges. Spectrum screen displays the transmitted waveform's envelope in frequency domain using fast Fourier transform of the sampled signal. Operation of horizontal and vertical adjustments as well as cursor control is similar to the scope screen. Waveform display can be changed from line mode to area mode. Frequency resolution ranges from 5 Hz per dot in high resolution linear scale up to 32 kHz logarithmic scale. The built-in tone generator is again a useful tool for transmission chain evaluation in frequency domain. A dual tone signal fed to the transmitter can be used to evaluate level of generated IMD products. The cursor set to tracking mode indicate the level of signal at the required frequency points. Switching the tone generator to output white noise, we can check the passband characteristic of the use filter or DSP processing of the transceiver. It is also possible to change the time constant of FFT averaging through the screen menu. The tone generator can be switched on or off directly from the spectrum screen. Spectrum screen is suitable not only for continuous signals, but may be also well used to observe effect of burst of pulses such as CW. In the following example, we demonstrate the measurement of occupied bandwidth in CW mode while transmitting a string of DITs. One cursor is set to the desired frequency and second to the start of the screen. Restarting peak hold, after a short time the delta marker showed the harmonic suppression as related to carrier level. When SMΩRF is connected to two sensors, it is possible to turn on automatic sensor switching. Auto sensor mode is indicated by gently flashing sensor 1 or sensor 2 light. This mode is useful for multiband HF-VHF radios or SO2R contesting where only one transceiver transmits at a time. Dual mode provides measurements from both sensors on dedicated dual screen. This mode is indicated by constant illumination of both sensor lights. Two sensors can be connected in several ways selected in Matter Mode menu. In dual mode, SMΩRF can provide measurements from two independent transceivers or two sensors connected in series to one transceiver with some additional device in between sensors, usually power amplifier. 2TX screen is designed to display transmit data of two independent transceivers. PA screen is designed for advanced power amplifier measurements. On the right side it shows gain between sensors as well as phase shift between sensors. 4-input mode is very special mode where SMΩRF does not use sensor and measures input signals directly applied to sensor ports. On screen it provides 4 bar graphs for amplitude and 4 for phase. Amplitude is measured in dBm or as a current amplitude ratio to one of the input. The dynamic range of this mode exceeds 90 dB. Unique feature of the SMΩRF and 4-input mode is its high accuracy for both level and phase measurement, making it irreplaceable bench tool for fine-tuning phasing networks, splitters, combiners, or even checking proper levels and phase distribution on antennas. For remote connectivity, SMΩRF provides built-in native Ethernet interface. No drivers installation, just a standard Cat5 cable to your local network switch or router and you can connect from anywhere. SMΩRF has internal web server allowing to connect from virtually any browser. Web server provides password-protected access to the most important network settings, backups and seamless firmware updates. Another server built into SMΩRF is VNC server with functionality similar to remote desktop. Any internet-enabled device can connect to VNC server using any operating system, doesn't matter if it's a computer, smartphone or tablet. Advantage of the VNC connection is that VNC screen is exact copy of the SMΩRF screen and all buttons and encoder are mapped to remote VNC keyboard. Zero learning curve and no traveling requirements if you need to change something on your remotely located SMΩRF box. For regular remote operation we are providing native, touch-friendly application called Remote Control available for both Windows and Mac OS X operating systems. Remote Control provides configurable top and bottom bar graphs having the same function as bar graphs on SMΩRF. Clicking on the bar, a menu opens where power range can be selected from a set of fixed values or set to auto range. This can be applied both to the bottom and to the top bar graph. For numeric readout, there are 6 positions where measurements can be displayed. 2 top yellow positions are designed to show powers. It is possible to set units and type of the displayed power. Remaining 4 positions, blue and orange, can be set to any function provided by SMΩRF. Remote control supports manual sensor change as well as auto sensor mode. In dual mode, it provides separate bar graphs for each sensor and 3 positions for numerical values. There are 3 presets available for quick store and recall of all settings. In the setups, it is possible to change connection settings, startup option, and few other program features. At the bottom of the setup window there is a slider allowing to limit data transfer between the SMΩRF control and the SMΩRF. It is a very useful feature if SMΩRF is located on remote site where you pay for data consumption. Another feature is a stay on top and compact mode, reducing remote control window size to be easily integrated between other windows of your favorite logger. SMΩRF is provided in 4 display colors: white, yellow, blue and green. Color has to be chosen at the time of ordering. It comes as a package with 1 sensor, pair of calibrated sensor cables, accessory cables, quick start guide and 3 built-in templates for simple out-of-the-box operation at 100, 600 and 1.5 kW levels. 7.3 and thanks for watching.